This is the Chapter 6 review assignment. So we're going to be going through all the problems on the chapter review assignment, so starting with number 1. Number 1 says compute the accumulated value of an ordinary annuity of $500 per quarter for 5 years, assuming the interest rate is compounded quarterly. So we're computing the accumulated value of an ordinary annuity, so we need a few things. R, or our periodic payment, in this case is $500. Our interest, our I, we take our 10% divided by 4 because it's quarterly, so we get 0.025. The number of times is 5 years times 4 times per year, which is 20. And we can use those two to find our accumulation factor on our table, which is 25.54466. So then we use our equation. Our total value of our ordinary annuity is 500 times our accumulation factor, which gives us $12,772.33. Number 2 is very similar, except now we have an annuity due. So compute the accumulated value of an annuity due of $100 per month for 5 years, assuming the interest rate is 9% compounded monthly. So we're going to start out the same way. So R is 100 because we're doing $100 a month. I is that 9% divided by 12 because it's monthly, so that's 0.0075. N is 5 years times 12 times per year, which is 60. So we get that our accumulation factor is 75.42414. Now, what makes this problem different from number 1 is that it's an annuity due, so it's paid at the end of every month. So we start out the same way. So we take our R times our accumulation factor, 75.42414. But then we have to multiply by 1 plus I, so 0.0075, because we have that extra compounding period. So we get $7,598.98. Number 3 is compute the present value of an ordinary annuity of $150 a month for 3 years. Interest is paid at 15% compounded monthly. So we're going to do similar. So our R is 150. Our I is 15% divided by 12, which gives us 0.0125. Our N is 3 times 12, which is 36. Since we're computing present value, we need a discount factor instead of an accumulation factor. So 28.84727. So our present value A is 150 times our discount factor, which is $4,327.09. For number 4, Mrs. Spector is updating her will and she wants to leave her granddaughter $1,000 a year for 10 years after her death. How much money will her executors need to invest at 4% compounded annually to accomplish this? Okay, again, we're going to be looking for the present value because how much do they need now? So similar, our R, they want $1,000 a month. I is 4% divided by 1, because it's annual, so it's just 4%. N is 10 years times 1 time per year, which is just 10. So our discount factor, looking at our table, is going to be 8.11090. So our present value is equal to 1,000 times discount factor, which is $8,110.90. For number 5, Scott and Ronnie need to save $30,000 to put a down payment on a house in 3 years. If interest at a local bank is compounded quarterly at 5% per year, how much must they save each quarter to make their deposit at the end of each quarter? All right, we're kind of going a little bit backwards here because now we're given the ending value. We want to find the monthly or the periodic payment, but it's going to be pretty much the same idea. So our total value, S, is $30,000. I is 5% divided by 4 because we're going quarterly, so 0.0125. N is 3 years times 4 times per year, which is 12. Our accumulation factor is 12.86036. So our periodic payment, R, is going to be our total divided by our accumulation factor, which gives us $2,332.76 or 75, depends on your rounding, dollars per quarter. Number 6, a washing machine sells for $450. If May puts $150 down, how much should she pay each month for the next 12 months if she finances the appliance? So assume that finance charges are 15% per year compounded monthly. So our total ending value is going to be the cost minus the down payment. So we're financing $300. Interest is going to be that 15% divided by 12 because it's monthly, which is 0.0125. N is going to be 12 because it's 1 year, 12 months. So our we're at discount factor is 11.07931. We use discount factor because we're talking more about present value. So our R is 300 divided by our discount factor, which gives us $27.08. Number 7, a tennis club has 300 members, and they want to build a new clubhouse at a cost of $750,000, so they establish a sinking fund which will accumulate this money in 2 years. The fund earns 12% interest compounded every 2 months. If all members are to pay equally, how much will their bi-monthly assessment be? Okay, so bi-monthly, every other month. So our total amount that we need in the sinking fund is $750,000. Our interest is 12% compounded every 2 months, so that's 6 times per year, so 0.02. Our N is 6 times a year times 2 years, which is 12. So our accumulation factor is 13.41209. To find our R, or our monthly payment, we take our $750,000 divided by our accumulation factor, 13.41209, which is $55,919.70. So that's how much the tennis club needs for every 2 months. But there are 300 members, so we're going to divide that by 300 to get the cost per member, which gives us $186.40. And last but not least, number 8. So a home computer was purchased for $100 down and $50 a month for 24 months. If the interest rate is 15%, what is the actual price of the computer? And then what's the finance charge? So let's start by finding the actual price of the computer. Our R is 50 because they're paying $50 a month. Interest rate is 15% divided by 12 because it's 12 months in a year, so 0.0125. Our N is 2 years times 12 times a year is 24. And we're going to use a discount factor because when we're finding the actual price of the computer, we're talking about the present value. Our discount factor is 20.62423. So to find our current value, we take our R times our discount factor to get $1,031.21. But then we need to add 100 for the down payment to get a total price of $1,131.21. So that is the actual cost of the computer. And to find the finance charge, well, let's see how much this person is going to pay. So they paid $100 already, and then they're going to pay $50 a month for 24 months, which is $1,300. So that's how much they're going to pay. So we take that minus the actual cost of the computer to find the finance charge, which is $168.79.